Hello everyone, let's code for next question. Okay, when two resistors that is R1 and R2 are connected in series, they consume 12 watts of power. That's when they are connected in series. When they are connected in parallel, so they are connected in parallel now, they consume 50 watts of power. What is the ratio of powers of R1 and R2? So the ratio, we have to find the ratio, that is power exhibited by R1 and R2, power consumed by. Okay, whenever here we know that the relation between the power and the resistance, P is equal to work done by time. Here work done is equal to charge Q plus V. Q times the V is called the work done of the wire by T, work done by time. Okay, here Q by T can be written as current IV. Okay, here we have to keep V as constant always. Okay, in this case, so normally for the power, the voltage is going to be constant for any cases. Okay, in the both the cases the voltage is going to be constant, the same potential difference is going to be used for this both the situations. Whenever you get these questions, it's they didn't say about anything about voltage. It means they're using the same voltage and same resistor, but the construction of the resistance is different. First time it is series and second time it is parallel. Okay, now so it is going to be constant, so we have to keep compulsory, we have to keep V. Okay, so we know that V is equal to IR, the Ohm's law. V is equal to IR, I is equal to V by R. We know that I is equal to V by I is equal to V by R. So in this situation, so I'm just substituting here. So V by R into V square by R. V square by R is the power formula. Okay, now for R1 the power is going to be P1. Let us consider R1, the power consumed by the R1 is going to be P1 and power consumed by R2 is going to be P2. Let us consider for this purpose, okay, to solve this question. So let us move the question. So continuing the question, just changing the marker right now. And okay, in the first situation they are connected in series and acquires a power of 12 watts and R1 and R2. We know that whenever the resistor are connected in series, in the first situation the resistor are connected in series, so this is R1 and R2. Whenever the resistance or the resultant resistance is going to, the equivalent resistance is going to be R1 plus R2. We know that, right? We have derivation for this also. Okay, we took this. So from this you can able to write this formula which I have written here, where the mouse point is exactly located, is R is equal to V square by P. So this is the formula we are going to use right here. So this is a very important formula. By using this by substituting this thing, the resultant power, okay, the resultant power when it is in the series is going to be V square by P resultant. P resultant is going to be equal to, in the first situation, okay, this is very important, is going to be 1 V square by P1 plus V square by P2. Okay, so here we are going to cancel these things by taking commonly outside. Now 1 by P1, okay, 1 by P is equal to 1 by P1 plus 1 by P2, 1 by P1 plus 1 by P2. What is P1? The power acquired by the power consumed by the P1 is R1 is going to be P1. Okay, resistor 1. Okay, so this can be written as by cross multiplication method. So P1 P2 by P1 by yes, P1 plus P2. So this is going to be the formula when they are in the series situation. Okay. So when they are series, they consume 12 watts. So this is very important, right? So I'm just going to substitute the value here. So here 12 watts is equal to P1 P2 by P1 plus P2, P1 plus P2. Okay, this is very simple, right? So the next thing is they are connected in parallel. I'm just moving to the next page to show that. So they are connected in parallel to a potential difference. This is very important, to a potential difference V. Okay, this is R1 and this is R2. Let us consider this is R1 and this is R2. So whenever the resistors are connected in the parallel, the resultant, the equivalent resistance is going to be 1 by Rp is equal to 1 by R1 plus 1 by R2. So here we are going to use the power value, that is P is equal to V square by R. So then R, which implies R is equal to V square by P. Then 1 by R can be written as 1 by R can be written as this is P. Okay, this is P, this is power. Power by V square. Very simple, right? So this is an important thing you need to take it down. And I'm just continuing the equation right here. This equation need to be continued with help of this thing by substituting this thing. So the total power by the potential difference is equal to, so this is in the parallel. Okay, and again, so we have took 1 by R only, 1 by R directly we can able to substitute it. So 1 by V square. V square is always constant in the both the cases, which we know that very well. Okay, P2 by, actually we, what the potential difference what we are using is constant. What we are using is constant, not the potential difference on the wire is not going to be same. Okay, here the potential difference is acquired by these both the resistor is going to be constant. So acquired by these both the resistance is going to be constant, but used in this circuit is okay, used in the circuit is constant in the both the cases. Used in the circuit, we have to note it down. Okay, used in the circuit. So V square. Okay, and by cancelling this, so into 1, so I'm just, we can able to write it as 1 by V1, 1 by V square, commonly outside 1 by V square, 1 by V square, 1 by V square, right? So the same thing, so here we are going to cancel these things. So this is in the parallel. Okay, the power consumed in the parallel is going to be 50 50 watts, 50 watts. So 50 watts is equal to P1 plus P2, P1 plus P2. Okay, this is what parallel. So for series we took the equation, that is we took the equation, that is 12 watts is equal to P1 P2 by P1 plus P2. Okay, what we can do with this both equations? Okay, I'm just splitting this away. So from these both I'm going to write as, yes, I'm going to multiply these both the equations, that is 50 multiplied with 12, which is going to be equal to P1 plus P2 multiplied with P1 P2 by P1 plus P2, P1 plus P2. So what we can able to do here is we can able to simply cancel these both equations, and we can able to get the value, that is P1 P2 is equal to P1 P2 is equal to 50 into 12, 50 into 12. So we get P1 and P2 value. So instead of taking this, we can able to take this itself. So for easy calculation, so by taking this, so we know that a plus b whole square formula. Yes, a plus b whole square formula. Everyone knows, right? A plus b whole square is equal to a square plus b square plus 2ab. I am just writing a minus b whole square plus 4ab. Whether this is right or wrong, so let us check. Okay, I am going to verify your doubt. Okay, I am just clear your doubt. So I'm just doing the right hand side. Yeah, RHS, I'm just doing the RHS value. So a minus b whole square, what is the a minus b whole square? A square plus b square minus 2ab, right, plus 4ab. This is RHS, the right hand side. So by doing this, we get a square plus b square plus 2ab. Right or wrong? Whether I am right or wrong? Okay, 2ab. This is equal to LHS and RHS, both are same, right? So what is the value of this? This is LHS, this is RHS. Yes, it is right. So this thing is nothing but, so this value, right? A minus b whole square is written here, and this value is written here. If you point the mouse point, you can able to find it very clear. So this is the basics actually. So we gone to the basics as now, and now you can able to move to the next thing. Here we are going to use p1 plus p2 whole square is equal to p1 plus p2, sorry, minus p2 whole square plus 4 p1 p2, right? We need to know about, we know that the value of, what are the values we know right here is p1 plus p2 and p1 plus p2 and p1 p2. The values we know is this value, we know this value, and we know this values. So we need to find this value, right? So from this you can able to understand what I am trying to do here. So I'm just moving this thing into the left hand side so that we can get a point, that is p1 minus p2 whole square is equal to s p1 plus p2 whole square minus 4 into p1 p2. Okay, you got it. I think you got the value right now. Okay, I think you got the value. Now let us move for the substitution. So I'm going to substitute the values here right now. Yes, p1 plus p2. So we need to find, yes, p1 minus p2 whole square, right? Whole square. What we have did is p1 plus p2 whole square minus 4 into p1 p2. We found the values here, so I'm just substituting the value. P1 plus p2 is equal to where the mouse point is present. So right now p1 plus p2 is equal to 50. P1 plus p2 is equal to 50. I'm just substituting the value here. So here 50. So as in the formula, whole square minus 4 into p1 p2. So we found the p1 and p2 also here, right here. I'm just drawing a box. P1 p2, 50 into 12, right? 50 into 12, 50, yes, 50 into 12, okay, is going to be equal to p1 minus p2. By taking square root on both sides, I'm just drawing this, so the square will be get cancelled in the formula. So So I have substituted, and then let's solve the question. So 2500 minus 4 by the 20, 200, 2 12s are 20, 2 12s are 24. So when this is going to be 200, 2 12s are 24, 24 into double zero minus going to be whole root. Okay, this is going to be P1 minus P2, and moving to the next thing is 2500 minus 2400 is 100. So root of 100 is equal to P1 minus P2. So which is going to be equal to 10. We found the value, right? So by knowing these two values, that is P1 and P2, by knowing these values, P1 plus P2 and P1 minus P2. So by adding these two equations, P1 plus P2 is written here itself, so 50. And we found P1 minus P2 is 10. By adding these two equations, so 2P1, so this get cancelled, is equal to 60. So P1 is equal to 30. P1 is equal to 30. The power consumed by the first resistor is 30, and then by substituting this equation in any one of these two equation, okay, by substituting that, okay, 30 plus P2 is equal to 50. So P2 is equal to 20. P1 and P2, we found P1 and P2. Okay, so the question asked here is, we have to find, we found the P1 and P2 value, we found P1 and P2 value, P1 and P2 value has been found, and P2 value has been found. P1 value is 30 and P2 value is 20, right? But what is the ratio of the powers of R1 and R2? Powers of, so P1 by P2. P1 by P2 is going to be 0, 0 cancel, 3 by 2. That is option C is the correct answer for this question. Thank you. This is a very long question. Okay, this is not that much important. They won't ask these kinds of questions, but to gain knowledge, you can able to solve these questions. Thank you.